Consider, what is this? 2-2, 40, right? So again, go to chapter 2. You would see 2-2-40. And we have this data set regarding what? Years and life expectancy. Okay, so again, this is years and life expectancy. How we're gonna create a time series plot for this one, okay? So let's consider following the steps for such. First of all, the x-axis should have the years, right? So in here, it looks like it started at 1960 and ended at what year? Okay, 2016, okay? And the second column is talking about the life expectancy for each year. Get it? Okay. Now, how to analyze this data or present it using a time series plot? First thing that we're gonna do is to select graph. It's okay. So go ahead, go to graph. Please click on scatter plot. Okay, so once you go to graph, click on scatter plot. Here it is. Okay, get it? Graph, scatter plot. If you click in there, the values in the x variable should be the time frame, which is in years. Get it? So again, the x-axis should always be the what does it say? Time for x-axis, right? Now the y variable will be the life expectancy. Okay, guys. Okay. Next one. Please click on points and lines, all right? So if we go here, you see the display, it just says points. If you want a scatter plot, it says lines. But if you scroll down in there, let's see. Okay. Please, well, not scroll down, actually highlight both, right? That you got the points and there will be line segments connecting each of those points. Get it? Okay, so again, please highlight those two, points and lines. Get it? Okay, points and lines. And then after that, we can put in the title for this. So if you scroll down, here it is. Okay. X-axis label, what is that? A time, right? In years, right? In years. Okay. And then y-axis label, that is what? Life expectancy. Get it? Okay. And then we put in here what? What are we creating? We're creating a time series, right? For life expectancy, right? From, it says 1960 to, what did it say? 2016, right? Did it say 2016? Okay, it's from 1960 to 2016. It's a time series plot for life expectancy, right? From 1960 to 2016. And yes, we can click on compute already and see what we're gonna get. So again, it's important to put titles in there so that we can verify what we are having right now, okay? So as we may notice in here, this is a time series plot now from, once again, 1960 to 2016. Get it, guys? So as you may notice in here, we can say, we can have analysis like what? So there's gonna be a lot of these, right? But at what year or years is the life expectancy increasing the most, right? So when you say increasing the most, then we can say we're talking about what? The slope is what? The slope should be what? In that case, is upright and also the what? Steepest. Right? So again, relative to the rest, where can you see an upright slope that is the steepest ever? for each of these, right? Can you verify some of them that looks the steepest so far in terms of its slope? Each line segment, look at that one. So can we verify? I would say this can be a good candidate, right? Get it? Okay. For the increasing the most in terms of life expectancy. So which among those can you see that's almost the same as that one, right?
At the end of 1960, almost where it turns
At
to
the end of 1960.
Yeah, 1968 to 1969.
1968 to 1969. Where is that one? In here?
Yeah.
Right after.
Here?
That one up, yeah.
This one? Okay. Get it? Okay. So as you may notice, what else? Can you see some more that looks like that line segment is typically the same as that one? Well, this one is almost that one as well, right? Good. So that will be a good candidate as well for the steepest slope, right? When you say increasing the most, it's the slope or the line segment going upright is really straight up.
Yeah.
Get it? Okay. Any other questions, guys? Oh, what about this? At what time frame can we see that is decreasing the most? So where is it decreasing the most? Let's color it pink. So that means the slope is what? Down right, the steepest down right? The more vertically down, let's talk about the cliff, Yeah. So, anyone in here, you can see that the steepest, the slope, 1960, what's this? 67 to 67 to 68?
Something like that.
Very good, right? Yeah. Where else are good candidates? I think that's the only one that looks like the steepest going down, right? Be good. So we can say in here, okay, so decreasing the most, we can say that one is happened in here from what? 68 to 69, right? Wonder what's happening during the 68 and 1968 to 1969, right? And the upright steepest, we say it's coming from what? What is this date in here? Time frame. Check it out, guys. That time frame. But this time frame, we can see that time frame is what again? We said a while ago. That's wait. That's the 68 to 69, right? Yeah, this is the 68 to 69. But that one in there, this is the 67 to 68, right? So in here, I'm gonna change this one instead to 67 to 68, right? Okay, and verify those other years. Time frame years in here where the increase or the decrease is the most when it is steepest, either upright or downright. Are we good, guys? Any questions regarding that? Get it? Okay. Next one. This one, we're going to analyze and present this data using dot plot. Okay, so we have in here okay, so here is, what's this? 2.2 table 8. Okay, so check on this one, guys. 2.2 table 8. This talks about what? Arrivals, right? So number of arrivals. Here it is. And let's see how we can create a dot plot out of this one, right? So this is a raw data of arrivals, and let's see how we can create an dot plot out of this one. Okay, so first thing that we're gonna do is as follows. Select graph. Okay, and then after selecting graph, we're gonna click on dot plot. Okay, so again, graph, dot plot, and then after that on the columns, we're gonna select arrivals, right, or number of arrivals. If you scroll down, we can put in here x-axis label. So we can put in here arrivals, okay? And the y-axis in here, we can put in here frequency, right? Of those number of arrivals, right? And the title, we can say in here what? A dot plot, okay? Of arrivals. Get it? Dot plot of arrivals. With that, let's click on compute and see what we can get out of it, right? So here it is. Oops. That's our data set for such. You guys, right? So with that being said, let's analyze this one. Let's say question would be as follows. Such as that, right? Braden, what do you think about that? Can you read this question?
What is the most frequent number of arrivals?
Thank you, right? So what is the most frequent number of arrivals for such? Thank you. So this one is what? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 arrivals, right? So what is the most frequent number of arrivals for such? Anyone? Most frequent, so in short. Number 6, as you may notice in here. Right? Okay. And how many in here? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, right? Yeah. Is it 11? Right. There are 11 of 6 arrivals. Right? Or the 6 arrivals, or arrivals of 6 happened 11 times, right? And that's the most frequent number of arrivals for this dot plot of arrivals. Get it, guys? So again, this is our analysis and definitely a presentation of the data set as well. Are we good? Got it? All right. Thank you, thank you. So with that,